I gave you a video on density. I would like to do one video, and so I'm going to, that works through a couple examples of density. So for the first one, I'm going to have a box, and we'll give this box some dimensions. We'll go 1 meter, we'll make it 2 meters high, and maybe 1.5 meters across. And let's give this box a mass of 2,000 kilograms. Seems like a lot, but think about how big this box is. This is 6.5 feet tall, 4.5 feet across, and 3 feet deep. That's a big box, 2,000 kilograms. That, I mean, I wouldn't move a rock of this size. That would be difficult. So let's see, I'm finding the density. So I'm going to need the mass divided by the volume, and that's going to give me density. So the volume of the box is just length times width times height. So I've got 2 meters, 1 meter, 1.5 meters. Pretty sure I did those out of order. 2 times 1.5 is 3 times 1 is 3. This thing is 3 cubic meters. So I have 2,000 kilograms over 3 cubic meters. I have 670 kilograms per cubic meter. This thing is probably made of some kind of wood. What if I said, I want to take this box and I want to cut a piece out of it. I'm going to cut a ball out of it. So I'm going to grab maybe some kind of a chisel and I'm going to cut a ball, and the ball is going to have a radius of let's go 0.5 meter. So if I do that, then if I'm looking just at the ball, I can find the mass of the ball. I know the density because I didn't change anything. It's still made of the same thing. If density is mass over volume, then mass is density times volume. And this is actually a relation that I'll use a lot, so I wanted to show that. Density was 670 kilograms per cubic meter. And I'm going to multiply that by the volume. I need the volume of a sphere. The volume of a sphere is 4/3 pi r cubed. So I'm going to get 4/3 times pi times 0.5 meter cubed, which works out to be 0.52 cubic meters. So I'll plug in. And when I do that, I end up with a mass of 348.4 kilograms. Maybe I'd like to know the density of the remaining block. If this thing is sealed, so if the space in here is now empty, and I don't mean filled with air, I mean empty, then I have a remaining mass of 2,000 kilograms minus 348.4 kilograms equals 1,651.6 kilograms. And I had a total volume of 3 cubic meters. Cubic meters, and that's going to give me 551 kilograms per cubic meter for this box with a completely evacuated spherical hole somewhere in it. That's how I'm going to find density or use density to find mass. I can do this with plenty of different shapes. I just kind of chose the shapes that we're going to come across the most often, which are a box, where the volume is going to be length times width, times width times height, or a sphere, where the volume is 4/3 pi r cubed. We might end up with a half sphere. In which case I would multiply that by a half, this by a half, and that's okay too. But those are the most common shapes that we'll work with. That's kind of how to go back and forth, and the big things that we need from this video. Density is mass over volume, or mass equals density times volume, both of which we'll use a pretty good amount.